it really is a great pleasure to be here. My name is Kevin Waterhouse. I'm the Managing Director of VCA based in our London office. We also have on the call, as I mentioned, Yongmin Lee from our Seoul office, who manages our APAC region. Simon Addison is our Technical Manager based in our UK office. And Rob Dupree is our our Product Manager, also based in the sunny UK. It's nice and warm at the moment, and we're enjoying balmy weather of almost 30 degrees, which for us is quite incredible. Anyway, so let me move on very quickly. First of all, just a very quick introduction as to who VCA are. We are a UK-based software development team. We have offices in the US, in Dallas. We have offices in Central Europe, and we have the office in South Korea. We're part of UDP, who some of you will know as a Korean manufacturer of cameras. We're not a startup business. We've been in this market for a long time. One of the very first companies in analytics. Started selling products in 2012, and we have over 500,000. In fact, actually, I did a quick check early last week, and we're now at about 560,000 licenses. So we're growing very well. Our business ethos is very clear. We wanted to make analytics as simple as possible to use. We obviously wanted to make it work and work effectively, and we wanted, most importantly, to make it cost effective. So we needed to make sure that everything that we do is based around those strings: make it simple, make it work, and make it cost effective. We only sell through global partners. We don't sell direct to any end users, and we typically sell in three areas: security, business intelligence, for example, retail and hospitality, and traffic management. Typically, our partners would be either distributors, some systems integrators, and we also have quite a big OEM portfolio. VCA has a wide range of rule sets. A lot of these will be very familiar to you. You know, we can obviously do things like zones and tampers and object trackers, but we also have some quite unique rules, things like logical rules, which gives you the ability to combine all of the other rules to effectively make your own rules depending on the scene that you're in. And we now have three deep learning based engines. So we have a deep learning filter, a deep learning object tracker, and a deep learning people tracker. I'd just like to point out here that within the Nx integration, there's three rules that are not quite finished yet. So the color filter, the speed filter, and a business reporting tool. All of those are being done and will be ready for the next release, which we think will be in about sort of 6 weeks' time. So customers always ask us, well, why do you have three deep learning engines? Well, we've developed three engines because we want to have particular types of rules and particular types of deep learning activities based upon applications. So, for example, our new deep learning object tracker, this object tracker has been developed primarily to handle very busy and very dense scenes where there's lots of motion going on, where there's lots of people there, or there's lots of vehicles there. We can detect people, of course, and we detect not just vehicles, but actually types of vehicles. So again, this is something that's coming in our next release. At the moment, we will just detect a vehicle, but soon we will be able to say, okay, not only is that a vehicle, we can tell you if that's a car or a bus or a truck or a motorbike or a bike. And it also detects bags very well. Our deep learning people tracker is really designed for tracking and detecting people, again, in quite busy scenes, mostly for business intelligence applications, for counting and queue lengths and occupancy and that type of application. But it also uses pose estimation. So pose estimation is where we're looking at 18 parts of the body to detect whether it's a person or not. So from that, we can generate rules, for example, slip, trip, and fall. The third engine is what we call the deep learning filter, and the deep learning filter has been designed specifically for perimeter protection and external protection. It detects just people and vehicles. It ignores everything else that goes on in the scene. Is there obviously to help reduce false alarms, as well as detecting people in very sensitive scenes. The key thing about these rules is that unlike most other analytics, we don't require any setups or any calibrations. The deep learning tools learn the scene very quickly, and understand what a person and a vehicle looks like. So there's no need to do complex setups and calibrations. It's a feature that we call instant analytics. So where do we see these three different rule sets being used? Obviously, there is some crossover. We detect people for all of them. Both the deep learning object tracker and the deep learning filter can be used for things like perimeter protection and false alarm reduction. The deep learning filter has a longer range, so it can look at long distance. It also works very well with thermals. The deep learning object tracker can be used in very, very busy scenes, very busy scenes with both traffic and people. And as I mentioned, the deep learning people tracker is primarily there for tracking people in very busy scenes. Now, VCA Core is available in two ways. So we can supply it as either server software, and the server software can sit on either Windows or Linux. It also works on ARM, so we've got it working on the Jetson series and even Raspberry Pi. It's very lightweight in terms of its CPU usage. Or you can have the analytics in a range of cameras that we manufacture in Vietnam. They have two ranges there. They have standard analytics range and an AI-based analytics range. And just for a couple of clarifications, you don't need to use our server software with our cameras. They are two independent things. So you basically have either the server software to use with any IP camera. So if you've already got sites that have got IP cameras in, or there's a particular camera that the customer needs to use, you can use our server software. If it's a new site and they want edge-based analytics, you can use the cameras. And in both cases, we have Nx plugins for both cameras and servers, and it's pretty much the same in terms of the rule sets and the setups and the usage. So it's a great advantage to be able to have both combinations. Standard analytics, just to give you an idea of the type of capacity. I'm sorry about the quality of this slide, I'm not quite sure what's happened here. So the Intel i7, for example, we can do up to 64 channels of standard analytics. And even a Raspberry Pi, we can do up to 5 channels of the standard analytics. When we move into the realms of the AI work, this is where we need a GPU. We've been very careful to make sure that we're maximizing the number of channels we can get for some fairly cost-effective GPUs. So as an example, you can see here that the GTX 1660, which is a fairly low-cost GPU, it can handle up to 128 channels of DLF, 16 channels of the people tracker, and up to 25 channels of the deep learning object tracker. We have projects running where people are running servers, sort of many hundreds of channels, and we do a lot of work to make sure that the balance is correct, and we help them specify the right CPUs and the GPUs. We got deep learning object tracker sites out there running sort of 50, 60 channels on single servers. As I mentioned, we have a range of cameras. These cameras can be supplied either as an OEM or very low minimum order quantities or unbranded. We can also supply the cameras as a Secubest brand, which is quite, I think, familiar in the region. So all of these cameras are using our standard analytics, and you can see there's a very wide range here: 2 meg, 5 meg, and 4K. Some fairly interesting new application type products, so some multi-sensor devices, and even a 180-degree single sensor device. We also have a couple of low-cost thermal cameras, one very low resolution and one 320 by 480, using our analytics. We've just introduced a range of IP cameras with VCA Nx deep learning on board. So these 4K cameras, there's a dome, a bullet, a fisheye, and a 180-degree camera. At the moment, the dome is available, and the rest will be coming through towards sort of the back end of this year. So the dome is available now. The bullet, the fisheye, and the 180-degree cameras are due in October. So these have not only the Nx plugin on board, but also our deep learning analytics. So everything I'm about to show you in terms of what the analytics can do is possible for either these edge-based or the server-based. And people always ask, okay, so you've got lots of rules, but where do we actually see the product being used? What can it actually do? So in security, the prime use has been really perimeter protection and long distance monitoring. The deep learning filter, as I mentioned, is absolutely brilliant for helping to reduce false alarm. We can also detect removed and abandoned objects. Our business is about object management, object detection. We don't do facial recognition. We don't do number plate recognition. We're solely about managing objects. On the data side, this is where we call it business intelligence. We can do things like occupancy, the amount of people going in and out of stores, the traffic flow around the stores, the amount of queuing, helping with queue management. We can provide heat maps based upon the amount of time people are in a certain area, as well as the number of people in certain areas. Obviously, footfall, fairly standard. But we do provide an awful lot of metadata for all of these applications. Work in conjunction with Nx. We've done a lot of the metadata integration, which means when their search function is available and being tweaked a bit, you'll be able to do some very, very extensive searches. For example, find a person wearing a red jumper in a certain area. On the Safe City side, we do a lot of work with traffic management, looking at the flow of traffic around cities, traffic violations, people going down streets the wrong way, parking in the wrong areas, even where pedestrians are walking. Perhaps there are times when pedestrians aren't supposed to be in a certain area, or we can look at where pedestrians are gathering and where they're moving to. We can do vehicle type analysis, and we can do speed analysis. The speed analysis is not something we would say is for enforcement. It's to give town planners and city planners and councils and police guidance on average speeds of types of vehicles in certain areas. So I'm going to show you some applications now on how we can use VCA. So this first one is looking at a thermal scene. So I'll make the screen a bit bigger in a minute. So this clip is looking at a thermal camera. It's in a very, very difficult environment. It's moving quite a lot. The camera's got a lot of shake in it. And we're typically detecting here about 100 and 150 meters away. So not a great distance for a thermal camera, but it's still reasonably difficult to detect in certain circumstances. And you see the quality of the video is not particularly great. But it's hopefully you can see this now on full screen. So you can see this is actually showing you this in the Nx platform, because we're showing the bounding boxes around the outside, the alarms going off. So at this point, we're just detecting that it's an object and a person. But you will see that there's lots of movement going on, which normally would cause some problems with analytics.
This is made by the thermal cameras with building analytics.
No, that was using a third-party thermal camera and using our server analytics. So that was using an existing install base.
I see.
It was a border that they're having lots of problems with people going over the border. They had cameras already installed on poles, and they weren't doing a particularly great job. So we were able to sort of help them detect people going over in the border area. This video is going to show you the deep learning filter. So here's a scene which is looking at a particular car park. And you'll see when we play this, there's an awful lot of very bad weather typically you might get in Taiwan with the typhoons. So you normally, again, analytics will pick up lots of false alarms here, but you'll see as I play this that whilst there's lots of movement going on in terms of the lighting and the rain and the wind and the thunder, we're not picking up any alarm events. The deep learning filter is looking at that scene and saying, well, there's no people in that scene, regardless of the fact that even the light shining in the right-hand side here would probably, in a lot of analytics, go off as a person. We're filtering it out and being able to sort of reduce the false alarm significantly. And again, this is server based, and this is running at 6 frames per second. So again, it's using a very, very low frame rate. This is a scene in an entrance hall, and here they're looking at people coming in and out. But what I'm going to show you here is our deep learning object tracker, not only detecting a person, but also detecting a bike and the fact that they've got a bag on them as well. So you can see we picked up here, we're looking at the box, we've identified as a person, and now we've been able to pick that up, that not only is a person, but they've also got a bag and as well as the bicycle. So very interesting at detecting, but all of that metadata is now being fed. Obviously, if it's an event or non-event, we're feeding the metadata. So you could do a search of people coming into an area with a bicycle and a bag, and you could even say a red bag. We do a lot of work in retail and hospitality type environments, and again, there's lots of people who can do counting. Of course, there are, but we think that our counting algorithms and our counting tools using the deep learning people tracker are better than anybody's. We can track people in very busy scenes. We can track people in very difficult scenes. So this scene here, whilst initially people think it's a relatively easy scene, actually with the flooring like this, and the lines on the flooring and the doors and the shadows and the shiny floor, that would create an awful lot of problems for most analytics. But because we're using the skeleton base, the pose analytics, we're saying, okay, we can see that that's a person because they've got heads and arms and legs, etc. In fact, we only need the shoulders and the head to determine that it's a person. Very accurately detected, the bounding boxes nice and secure around the individual targets.
A quick commentary here, Kevin. So it's really great that we can identify different kind of objects, and then like you said, we detect a person, a bike, and a bicycle, and a bag. So those kind of metadata, they will be able to be searched inside Nx. So we can form some kind of forensic search function for the user to key in those keywords generated by VCA, and then we can narrow down a whole day, even a whole week video with those video with the metadata tags. So that will help the search function much easier and faster.
Yeah, absolutely, Jason. So all that metadata is going to be available. So just a quick scene now of a traffic junction. Again, lots of motion going on. Again, using a camera that's already in place, not an edge-based camera, because cameras are already there and people want to get most out of that. This could equally be on our API cameras or as a server. Let me run this one for you. So you can see we picked up, there's a bicycle in the top, and now we're picking up cars. So we could do speed there, but not just to give you average speeds. And the one great thing about the deep learning object tracker is it works very, very efficiently at night as well. So a lot of analytics struggle with car headlights. Because the deep learning engines are trained on vehicles, it ignores headlights. So it's being able to pick up individual types of vehicles. So here we're just processing lots of cars coming through. We're given a probability on whether we think that car is a car or not. We've now come through with a big truck there. Different interpretations on where you are in the world, whether that's a truck or a van, but in some parts of the world they consider that as a truck. Okay. I mentioned earlier that we were looking at some reporting tools. We have a reporting tool that's now being added to the Nx platform. So as well as providing the capturing of people and the metadata, we can now, or very shortly, we'll be able to provide full reporting capabilities within the Nx platform. So this is a product that we call DataPoint. This will give you both graphical information and reporting information. It will also do things like heat maps in either graph format or Excel format or pictorial format. You can look at heat maps and say, okay, you can look at dwell times, the amount of people are spending in certain areas, or you can look at the amount of traffic flow in each of those areas. So this will be a new tool that we're going to be launching probably in the next sort of 30 to 60 days. The development is pretty much finished. This is a tool that we've been selling ourselves quite significantly over the last year. So, you know, it's not a new development. We've just had to add it into the Nx platform to give you that graph and reporting tool. So where do we see the advantages of our plugin? The configuration tool, there are certain limitations as to the type of things we could do with the Nx plugin. So we've developed a configuration tool which gives you a much wider range of tools. But you'll see, because Simon's going to demonstrate this in a moment, that actually the look and the feel is exactly the same as the Nx feel. So you don't feel like you're coming out of an application and back into it. It's very, very close. We've done a very, very tight metadata level integration. Again, when we show you some of the samples, Simon's going to show you in a moment, you'll see that the bounding boxes are very tight to the people. We've done a lot of work to make sure that the detection is accurate and the look and the feel is very accurate as well. We have a very, very effective licensing fee. It's basically a one-off payment, that there's no ongoing charges. As I mentioned earlier, we're very strong on reducing the amount of hardware costs to keep the overall cost of ownership down. We have a range of cameras that are available to you, either as an OEM brand or an unbranded. And basically, it's the same plugin features and the same look and feel, whether you go for the server software or the camera option. So you could, for example, have a customer that's got existing cameras already. You could upgrade those with a server, and they might want some new cameras as well. And you can add the API cameras, and you've got the same look and feel and the same plugin for both the tools. We're going to give you a new business intelligence tool for graphical reporting and heat maps. We think it's a very important thing that you know that the VCA team is here for you. We get involved in a lot of projects because we sort of know analytics pretty well. We're able to sort of give guidance and give help and give support to our customers when they're talking to their end users. Happy to participate in presentations. One of the things we do quite a lot of is to get demo clips or evaluation clips from a customer site, and if they want to test something. If we can get a clip, we would then run that through the engines and give you the results and show you what it can do and what it can't do. And one piece of good news for you is that we have negotiated a very special price for all the Nx partners. So you haven't got to be a signed up VCA partner to get this price. You're an Nx partner. As an Nx partner, you're a VCA partner. Therefore, you're able to qualify for our better pricing.
Wow, that's very nice. Thanks, Kevin.
That's our pleasure.
I think I didn't see that in previous webinar.
No, it was only finished. We just finished the negotiation over the last week, so it's all good.
Yeah,
so you got one up on the European people for sure. Yeah. Okay, so I'd like to now hand over to Simon Addison. Simon's our technical manager, has been working very closely with the Nx team, and he's going to give you a demonstration of VCA operating within the Nx environment. And I know, Jason, you've already spent quite a lot of time on this, so I'm sure you'll be able to sort of add your weight behind the argument on some of the things that we've been doing.
Okay. Thank you, Kevin, and thank you to Network Optix as well for giving us this chance to show you what we've been developing. So what I'm going to do is just see if I can share my screen with you. So just give me 2 seconds while I sort that out. Okay.
Okay, we can see your screen.
You should be able to see it. Yeah, so hopefully you should be able to see my presentation screen. Okay, so you can see it, can you?
Yes, we can.
Brilliant.
Thank you.
So what I'm going to do is I'm going to split it into 2 parts. So I'm just going to do a few slides to walk you through the requirements for installing the VCA Nx plugin, the setup and the basic features that you can use. And then I'm going to move it over to a live demonstration where I'm just going to configure a camera inside NX Witness and get it configured with analytics. So you can see the process of how easy it is. So the first thing I'm going to do is just walk you through the type of environment you need. So I've got a diagram on the right-hand side to try and give you an architectural overview of how the system's put together. So we've designed our Nx plugin into sort of 2 to 3 components. 2 main components, which is the Nx plugin itself, which sits next to the server. And then you have the second component, which is our core analytics server, our VCA Nx server. So typically the idea is that can sit either on the same machine or it can sit on a completely separate hardware platform. Because of the amount of power it does take to process some of our analytics features, we tend to suggest that you would put it on a separate hardware platform. Then you also have the VCA Nx configuration tool, which I'll be showing you in a while. And then you have the sort of standard Nx Witness architecture where you have the client, you can have the server, and then you have the cameras talking to it. On the left-hand side, I've just outlined some of the requirements for installing our VCA Nx server. So, we support Windows. We also support a Linux Ubuntu installation as well. You need a NVIDIA GPU graphics card with a compute capability of 7.5 or higher, and you need the CUDA toolkit installed. All of that can be downloaded from the NVIDIA websites. The installation process for both Windows and Linux is fairly simple. So with Windows, it's just an executable self-installer, which you can select which component you'd like to install. And with Linux, it's just an SH file, which you define which components you'd like to install. As Kevin mentioned earlier, our analytics service does require licensing. So that license can be put in through our licensing module. We've made a web page available for you to allow you to put in that license in, and for convenience you can add that web page to your Nx Witness system just so that it falls more in line with all of your other systems that you have in Nx. Once you've got it licensed, you then just need to configure your Nx server systems in order to point to that plugin. So it's a very simple process. It's outlined in the documentation that we can provide to you. And then once you've got your server set up, you then just enable the plugin for the selected cameras, and then you can start configuring the analytics. In order to configure the analytics, you can use the features which are built into the Nx Witness client. What we've done is we've actually designed our own configuration tool in order to give a more complete experience. There are some limitations, some factors which we weren't completely happy with, so we designed a separate integration tool, which I'm going to show you. So that configuration tool will look very similar to the Nx system itself. We've tried to make sure that it looks very seamless in its turnaround. Okay, so what I'm going to do now is just move over to a live system where I've got Nx Witness running. Hopefully you can see the screen that I've got up at the moment.
Yeah,
I've got Nx Witness client running in here, so I'm just going to log on. So this is hopefully something everybody is used to seeing. And I'm just going to log in. So we have some cameras here which are running already. But for the purposes of this, I'm actually going to go for a brand new installation. So I'm just going to go to a new layout just so it's easier to see. And I'm going to add a new device. On my system, on my network here, I have running a RTSP server, which is giving me lots of RTSP streams. So I'm hoping that I'm going to connect to a stream now. Okay, so I found my camera and I'm just going to add it. And then we can close that down and give it a couple of seconds and we should see the camera suddenly pop up on here for us to use. I'm just going to drag it into the middle of the screen so we can see it. So this is just a pre-recording, it's just a typical clip that we use. So the first thing we're going to do against the cameras, as we do with all of the cameras in Nx, is that we need to define a recording schedule if we're going to do any kind of recording. So I'm just going to set one up just for random. And then the next thing I'm going to do is just enable the plugin. And then once I apply it, as I said, you'll see that all the features are available for you to configure inside Nx. But we have developed our own tool for providing a more complete experience for doing that. So the last thing I'm going to do here is just tell the annotation to appear on the screen. And now that I've done that, you can see the system's already starting to process standard analytics through the system. So that's already using our plugin straight away. So from here, I'm just going to move over to the plugin that we've developed. Sorry, the configuration tool that we've developed. So you'll see straight away the configuration tool looks very similar to Nx, and we've designed it to make sure that it does. So again, I'm going to select my server to log into. I've already saved the username and password. So what this tool does is it gives us a filtered view of all the cameras which have had the VCA Nx plugin enabled against it. So I'm just going to select this camera. So the first thing we can do is we can define the type of tracking engine that we'd like to use. So at the moment we're using a standard object tracker. If I then move over to our deep learning object tracker and enable it, you'll notice in the background immediately all of our objects are now being detected and being automatically classified. So this is our new object tracker coming in, and it is automatically picking up those objects and tracking them throughout the scene. And as things start to settle down, you'll see these objects are now being nicely tracked. The stationary objects will slowly move into the background, and we can now create rules based on this. So to show you a very simple rule, I can go into my rules options inside my configuration tool, click on add, and then you get a selection of all the rules which are available for you to set up. So the purpose of this, I'm just going to do a very simple rule, which is just an intrusion rule. I'm going to define an area where I'd like to detect movement. So I'm going to say, for instance, down in here. And I'm just going to apply it. And it's that simple. So what we have now is a rule which is appearing on here, the zone. And when objects enter that zone, it will trigger an alert. So the only other thing we have to do in Nx now is decide how we're going to react to that event. And that's defined in the camera rules. So in the camera rules, you simply add a new rule, select the camera, select the rule type that we'd like to act to. So we selected the intrusion rule, and then define how we're going to do it. So I'm going to do a desktop notification. I'm just going to say it to come up every second just to show you how quickly it comes up. And now we're immediately getting alerts up. So every time there's an object entering the zone, we're getting an alert up. So in the same way, you can create bookmarks in order to preview the recordings later on in your history. And that's how you set up the system. Thank you very much.
Thanks, Simon. Like few things to share here based on my testing. Like one thing I really like is that when we are installing the configuration tool, the system will actually automatically copy and paste the required plugin file to the dedicated folder inside under Nx server. That's something really nice. Some of the users might find it difficult to find the right plugin folder to paste the plugin file, but you guys made the process easier. We just click and then the plugin file will be copied right there. So that's something really nice. Yeah, and the other thing is that we can, like, based on my experience of testing, I can tell that the bounding boxes are located at a very nice and accurate location, even though the vehicle is driving at a not very fast, but at a certain speed. But we can see the bounding boxes are very correctly located on the object. Yeah, so I can tell you guys spend a lot of efforts making the integrations, and we really appreciate that. Thank you.
Thank you. Yes, we did. We spent a lot of time making sure the bounding boxes are very tight to the objects that we're tracking.
Yeah, that's one of the most often seen issue, that the bounding boxes sometimes are look like they're tracking the objects, they're trying to catch up with the object. So, but the bounding boxes the VCA plugin created are very accurate. Yeah, that's great. Yeah, so I think that's the live demo part, right? We have some questions coming in, so maybe we can start the Q&A session, and while having the live demo site right here, maybe we'll use it during the Q&A. Would that be okay for you, Simon?
If I can help you with it, yeah.
Fantastic. So yeah, there's a first question that some of the attendees, they want to have the presentation file. So Kevin, would that be possible? We can share the presentation with our attendees after the webinar.
Yeah, I'll send you the link to the drive, Jason, and you can distribute that. Yeah, no problem.
Fantastic. Thank you very much. Thank you. And there's a question from Benny. So the question is that still applied to DORI when trying to detect all objects in the scene? DORI. Andy, Kevin, or everyone, do you guys know what does DOI, the short form, mean?
I do
or
not.
Benny,
No, don't know what that
Benny,
means. Unless it means IR conditions, I don't know.
Or Benny, could you elaborate more about your questions about DORI? Yeah. Okay, we'll wait for your further elaboration on that questions, okay? Okay, got it. Let's detect, observe, recognize, and identify. Is that still applied to when trying to detect all objects in the scene? So I guess the question means, can the VCA plugin doing detect, observe, recognize, and identify at the same time?
Perhaps I can in on this one.
Yeah.
So,
Yeah, go
hi,
ahead.
Rob Dupre. I'm the product manager at VCA, and one of the other hats I wear is around the AI technologies and how our trackers work. And so that kind of sequence of events in terms of detection and then recognizing and then identifying, we do that in some cases. So our motion-based tracking with respect to using the deep learning filter. So that's kind of like a two-stage process. We detect motion in the scene. We draw bounding boxes around the object that is moving, whether that's a real object like a car or a vehicle, or maybe it's like an illumination change or really any change in pixels. And then we use the deep learning filter to analyze that bounding box and tell us whether or not it's something of interest or not. So whether or not it's a person or a vehicle. And so in that situation, you have roughly that breakdown of detecting something, recognizing it, and then obviously identifying it. What you're seeing on the screen at the moment is our deep learning tracker. And that actually works in a slightly different way, in so much as our deep learning model looks at the whole scene. And then as part of the output of that, it says where the objects are and what they are in kind of one step. And then on top of that, we then track those objects. So we do in a slightly different order. We do our detection, classification, identification in one step, and then the tracking between the frames is done after that. So we, depending on the tracker and the use case, we do that kind of order of events slightly differently, but ultimately what it ends up in is bounding boxes, identifying objects between frames, and of course our metadata, which we produce about those objects, regardless of our tracker, is all the same. So if we can give you a class, we'll give you the class. If we've got color, we can give you color. We can obviously tell you where it's been and the history, the size of the object, all that kind of stuff. And so the nice thing about VCA is that regardless of which tracker you use, the metadata that you get out will always be the same. You'll always get the same type of information about your object that you can then consume inside Nx and do things like searches on.
Got it. Thanks, Rob. And there's another question from TJ, our partner from Singapore. So the question is, can we adjust the thickness of the bounding boxes? So in one of the demo, when the vehicle exits the viewing angle, the bounding boxes stick on the scene for a while. So I think the question could be also mean, if we find a constant latency between the bounding boxes and the server, is there a way we can adjust maybe like the milliseconds between the bounding box and the object?
It's not something we've implemented at the moment. Typically, we find with our usual deployment of this system, that latency is usually quite low anyway. And so what we try and do, and this kind of goes back to what Kevin was saying at the beginning of the presentation, is we're trying to keep this sort of as simple as possible. And what we find is the more options you provide for things like this, potentially the more trouble you can get in respect to how accurate your analytics are. So typically we don't find it a problem. We do have some settings for our trackers for things like what we call object hold on time. So when an object comes to rest, or when we detect an object and it maybe no longer moves or exits the scene, for example, we do have a variable that you can change that will allow you to sort of stop tracking quite quickly after that event happens. So there are a few little things that we do with that, and they're actually quite wide-reaching in our applications. So, for example, the deep learning tracker, because it doesn't require motion, we can detect stationary objects, for example. That's very useful in some situations. If you had, say, a car park, and you wanted to count the number of cars, then we can obviously do that, and we don't require that motion. But obviously, if you're doing something like you're looking for maybe a traffic offence, and you might have parked cars always present that are, say, legal, you obviously want to be able to ignore those things. And so we have settings inside our tracker that allows you to say, only detect an object once it started moving, or only detect an object when it is moving. So there's a few little settings in there, and those kinds of tweaks can be used to kind of perfect the type of objects that you want to receive information about.
I see. Noted. And one question from me, actually, while I was listening to Kevin's presentation, I noticed that there's a slide about using pure CPU and Raspberry Pi for video analytics. I just want to confirm, is that for the traditional video analytics without AI?
Yeah, there will be. Yeah, the Raspberry Pi is not a GPU-based tool, so it will be the standard analytics. Yeah.
And the standard analytics also work with this VCA plugin tool, or it's based on the generic event?
Yeah, no, it's exactly the same. It's exactly the same. All you're basically doing is saying, okay, if you want to run the AI stuff, you select one of the deep learning engines. That's all. Otherwise, you're just running the standard object tracker.
Okay, got it. So the setup process is all the same, just the background engine is different. Okay.
Yes. Yeah.
That's great. That's actually, I don't know about you guys, but that's my first time seeing a video analytics that can run on Raspberry Pi for surveillance usage. That's pretty cool. Yeah, that's very cool.
Yeah, and I think we've looked at also the Jetson range, so the Nanos and the Xaviers, so they will support the deep learning filter as well.
I see. Cool. So, okay, there's one question from Sean. Can the VCA separate bike, car, and truck as the vehicle? Yeah, I think the answer is yes, right? There's a deep learning module that can do the vehicle type classification.
Yeah, under the deep learning object tracker, you can classify different types of vehicles. That's not yet implemented in the plugin. We use it in our standard analytics, but it's not yet implemented in the plugin, but it will be done very soon. Yeah.
Okay. And when, for example, if we have more capability from the VCA server, so do we need to upgrade both the server software version and the plugin, or the plugin will be always the same? We just need to upgrade the server algorithms.
I think we're trying to tie it in with your next release, your 4.3 release, is it? I think to get all that together as one thing. Yeah.
Yeah. So when we release the new thing in VCA Server, the plugin will have our VCA Server software embedded as well. So all you'll need to do is upgrade your plugin, and everything will be done at the back end as well. So all the new features will be there, all the new integration between Nx will be there. So it's just one thing you have to do.
I see. That's great. That would be great. Yeah. Everyone, any questions?
Yeah. I have a couple guests that shy to ask questions, so ask me to help. The first one is about the camera brand. No, the camera is all made in Korea or anywhere?
Vietnam,
right? Okay, cool.
Where we have two manufacturing facilities, so it could be either Seoul or it could be Vietnam, but it's one of those two.
I see. The branded one and the unbranded one are all in Vietnam, right?
So it can either be OEM, which can be as little as a sort of minimum order quantity of sort of maybe 50 units, or it can be unbranded with no minimum order quantities. So yeah, either one of those two are available.
I see. And another one is, since you have the report, right, for like smart retail, and how about the vehicle counting? I mean, you can recognize the vehicle, right? Do you have any report about the counting, vehicle counting or people counting?
I think Simon might be able to help me out with this. So I think at the moment it's just counting people, but it would be possible to sort of. So we will count vehicles, but we don't do the count reporting yet. We're doing people count reporting. So we can provide the metadata for the cars, etc., and you can produce it from that, I would guess. But Simon?
Yeah, absolutely, you're correct. Yeah, so at the moment with the Nx plugin component that we've got, we can certainly identify the vehicles, and you can trigger events to occur based on a particular object crossing a line or entering a zone, but we don't have any counting currently associated with that. It's something which I think we are looking at doing, but at the moment you would usually have an external tool which you can then collate all that information together and create your reporting.
Okay, no problem. Thank you.
I think you're on mute, Jason. Sorry.
Thank you, Kevin. Thank you. Yeah. So for the data point dashboard application that is to be ready soon, so that is not only for the smart retail, right? The users can also use that for example, smart traffic analysis and collect different kind of vehicle data from the VCA server. Would that be possible to use for other use cases?
I would need to check that. I don't see why not, actually, because it is just a graphical report of count data. So I will check that one and answer that one for you, Jason. Yeah.
Okay, thank you, Kevin. Okay. There's a question from Sean about what's the difference between DL object and DL people tracker, and what kind of thing we should choose those trackers.
Rob, did you want to answer that one? Difference between DLOT and DLPT?
Sure. Yeah. So again, this comes back to the reason why we have multiple trackers for different scenarios, and it's really about optimizing performance in different environments. So the deep learning people tracker does what it says on the tin in respect to it only tracks people. It has the added benefit of also providing the skeletal information. So we can give you information about the location of 16 to 18 key points of the body. So things like legs, arms, shoulders, and some key parts of the face as well. So it's really designed for kind of the retail application, or really kind of tracking people in a relatively close field of view, where you want highly accurate counting of people, or you want access to this additional metadata about the key points. And so when we train that algorithm, we train that in mind. So it's not trained on grainy infrared dark scenes. It's trained on relatively well lit indoor scenes that you would typically find in things like railway stations or retail stores or things like that. The deep learning object tracker is a little bit more generic. So it detects objects of various different classes. So that includes people. It includes obviously vehicles and vehicle types, and of course things like bicycles and bags that we showed you in the video earlier. And so that really is designed with a bit more of a generic use case in mind. So it can be used for things like security. It can be used for things like retail. It has these use cases about things like monitoring car parks and various other tasks. And again, the training data reflects that. The use cases obviously are driven by what objects you're trying to detect and so on. And likewise, the deep learning filter, which is built on top of our motion-based tracking, that is really designed and trained with kind of the security use cases in mind. So we do train that with long range, grainy, IR, some thermal imagery as well, to improve that performance in the use cases where you have things like perimeter detection or maybe sterile zones. So we have in the presentation a kind of a Venn diagram where you can see what the trackers do and what kind of use case they are applied to, and there is a lot of overlap, as I said. So the deep learning people, deep learning object tracker, and the deep learning people all detect people, for example, but they do that at different ranges and they do that in slightly different environments. So it's really about just identifying what your use case is, and then what we are hoping is that we have not just a generic tracker that will hopefully do what you want, but hopefully a targeted tracker that will give you good performance in that use case. And we're constantly developing those. Our data sets, which is really the foundation of these algorithms, is always being developed. We're always improving and increasing those data sets. And so we hope that the algorithms will become more accurate in their use cases as time goes on.
Another question came in. So what is the minimum resolution and frame rate to perform the analytics?
That's a very interesting question. So we normally would say 640 by 480 is the minimum resolution we would like to operate at, and we would normally like to say 12.5, 15 frames per second we would like to operate at as a minimum. But as I think I showed you there, that one of the video clips we had was actually down at 6 frames per second, and the thermal camera was a lot less than that. Was a 320 by 240 resolution. So
300 something, yeah.
Yeah. So I guess we would like to do 640 by 480 and 12, 15 frames per second, but we can see that we can operate down at 6 frames per second and down at 320 by 240 on that thermal camera.
Yeah, I think just to chime in there, I think it's worth adding that we can support varying frame rates and resolutions. The main impact is on the resource on the hardware. So the higher the resolution that you pump into our system, then the less channels you're able to cope with on that hardware.
Yeah.
So we always found that the 640 by 480 resolution, 15 frames per second, was the optimal, the sweet spot, the perfect place where you were getting good analytics and you were getting good channel capacity on your hardware.
So the other questions around would be: is there a maximum resolution so far, like 4K, or 5 megapixel as the maximum that you recommended to use for the video analytics? Like sound of the camera that was multi-sensor with very wide viewing angle.
Sure. Yeah. So
high resolution at the same time.
Yeah, so actually, the framework itself will support pretty much anything you put into it. So the maximum resolution will go up to, it will go up to 8K if you really want to push it that, and the analytics will scale to that. So the problem with it and the wastage comes in when we put our video feed through our model. We actually downsize it to around the 480p. That's the input we have to rescale it to. So there's a lot of wasted energy there. If you put in a massive image, and we're going to scale it all the way down and then do the analytics on that anyway. But you can do it, and the advantage of doing it, of course, is that we will then obviously scale up our objects to match your input frame rate. Your input frame size. And so if you wanted to record the output of core, so when you're piping the data from into the Nx platform, for example, you'll get our annotations on top of your 4K or 8K image. And so you certainly won't do anything bad. It will probably improve the analytics because we will retain some of that information when we scale it down. It really just comes down to the fact that it's a little bit of a waste of energy. And so most of our CPU performance is done is occupied by decoding and encoding images, and so if we can keep it at 480, then that's the optimum for us. It's very little change.
One more question. Since you have a fisheye camera and the multiple lens camera, right? So all of the video analytics work on them as well, right?
Yeah, so motion detection on the fisheye is no problem. The classification detection will degrade towards the edges of that fisheye image without the dewarping. You will see some degradation in classification quality, but certainly in the center of the images, we can do relatively good detection. What I would say is typically your fisheye is mounted on the roof, and so you'll have like a top-down field of view on most of your objects. And so for things like people detection and counting, using some of the deep learning algorithms, that's not the optimum field of view, but it will work. But again, it just depends on what level of accuracy you're looking for.
Okay.
I've got a an example I can show you of the 180-degree lens using the deep learning filter. If you want to give me back the screen, I'll quickly put that up.
Sure. Let me do that. Yeah, I remember that video. That's pretty cool. Make presenter. Okay.
Okay, so this is using a 180-degree camera, and we're running the deep learning filter through this. So this is just picking up people and/or vehicles. You can see here we picked up the vehicle coming through the trees, and we'll track that and we'll see how far that goes. But whilst this is all going on, there's obviously lots of motion going on in the trees, lots of shadows. You can see we've still got the vehicle, still got the vehicle, still got the vehicle, still got the vehicle, still got the vehicle. Oh, I've lost it about there. But now we're picking up these people coming through. And we're still not picking up any motion or any rubbish from the trees or the shadows, even though the people are now walking between that. So I think that gives you an example of the sort of typical range, I guess. Obviously,
Yeah.
You know, this is a nice picture, but this is using our 180-degree single sensor camera with the deep learning filter on board.
Great.
Cool. Cool.
Okay. So I think we can have our last questions for today, maybe. So let me check on that. There's a question from Sean. Hold on a second. I lost my question bar. So for Nx virtual camera, okay. Simon, I don't know if you tried this before. We have a function called virtual cameras where we can upload offline video into Nx, and then we create them as a virtual camera, like video from GoPro or video from some like drone or wearable camera. So once we upload the video into Nx as a virtual camera, are we able to use the VCA plugin to analyze the virtual camera stream?
Yeah, so you're right. I haven't actually tried that, but there's no reason why that shouldn't work. So we are fed the information from Nx. So Nx will be passing us the video stream. So we don't know where the video stream's coming from. So it should work absolutely fine, and I can certainly test it and confirm it with you later on.
Okay, thank you. Thank you. We will also test that. Yeah, I didn't thought about that. I will also test that. Okay. And
I'm just showing you an image now of the nighttime, so you can see we're not picking up headlights and all that type of noise.
oh. Well, it's really nice. It's a very wide angle, high resolution, cover a very large scope. Oh.
Yeah.
Hmm. Oh, by the way, the last comment, like how would our partners going to contact you? Like, should they contact you or should they contact Junming? Or can you put the right contact information on your screen so that the partners can take a picture of that and then reach out to you if they have further questions about VCA and your camera?
Yeah, you can do it to info@vcatechnology.com.
info@vcatechnology.com. Okay.
Yep.
That's great. So I think that's info@vcatechnology.com. Got it.
Yep.
And hold on, I think we have.
And if you mention that you've been on the Nx webinar, then we know where you're from, and we can sort of make sure you get the right support and pricing and everything else. Well, looks like we may have lost Jason, Andy.
Yes, it looks like it's gone.
Yeah.
Yeah.
Just stops.
Can you see if there's any other questions, or are we finishing the
Yeah,
webinar now?
yeah. So I think it's time, right? We please email us for your more questions, right? And whatever you need, just contact us, right? Contact Nx or contact VCA. Okay.
And I'll send you the presentation link, and you can
Yes.
send that out to the
Yes.
delegates. That's fine. Well, I would like
Yes,
to thank you all for attending. I hope you found it very useful. It's great to hear from you all, and we very much look forward to supporting you and helping you.
Yeah. Thank you. It's a great webinar. Thank you.
Thank you very much.
And thank you everyone to join this webinar. And looking forward to all your questions. Okay. Thank you.